My name is Stephen Bilo, and I work at Red Hat and based here in Singapore. Just a little bit about myself. My experience is split 50-50 roughly between development and operations. And about 5 or 6 years ago, I was wondering what to do. Should I focus on development or should I just focus on operations? And that's when I met Amazon Web Services for the first time. I found myself in a workshop, and from that day onwards, I was hooked. So why? Why was I hooked? As Werner Vogel said, the CTO of Amazon Web Services, he said, cloud is liberating. It breaks down barriers. It takes away the constraints. And that gives you freedom, and the freedom to experiment, make mistakes, go back and try again. And that, in turn, gives you agility. And agility also spawns innovation. And it's proven that innovation creates more profit. So I'd like to ask a couple of questions. So I'd like to see a show of hands. Please don't be shy. I will not pick you out and ask you up here. But the first question is, how many of you here have played with or just tried Docker containers? Please lift your hand. So I think that's about 30%. Okay, keep your hands up. How many of you, with your hands up, have used Docker in, or are using Docker in production? So put your hand down if you are not using Docker in production. That's about maybe 5–10%. Okay. So one more question. Before today, before this slide was put up, how many of you have heard of and understand a little bit about OpenShift? Well, about 20%. Okay, encouraging. So if you are thinking about using Docker technology, or you are using it already, what I want to show you today is how you can take your Dockerized application and you can safely and easily deploy it into any infrastructure location of your choice, be it the public cloud, private cloud, on-premise, off-premise, physical, virtual, or even on your laptop. So briefly, what is OpenShift? So OpenShift is a platform as a service. That begs the question, what is a platform as a service, a PaaS? So I explain it this way. Developers like to, or most developers like to or should, focus on writing good code. They want to write a great application. They generally are not interested in all of the bits and pieces around the application, the infrastructure, for example, which are essential to make the application work. So these are things like the network, the storage, load balancers, firewalls, logging and monitoring, all of these things generally developers are not interested in. So the platform as a service provides all of this stuff. So the developer can focus on writing great code. And this leads on to the OpenShift provides a development environment on demand, so self-service. The developer can go into OpenShift and through the website, web UI, click together an application with all the dependencies, with all of these best practices, using Docker images and such. It also provides a whole set of Docker images with all the languages you need, all of the frameworks you might need, and also databases. So you can take all that wealth of baked-in goodness and click together your application. You can do that through the web interface or through the command line. OpenShift will also automate your application lifecycle. So for the developer, it helps the developer with the build cycle and also with the deployment and also maintaining the application and upgrading the application. And this is also enabling collaboration because these things can be shared. Docker containers and definitions of applications in OpenShift called application templates can be shared amongst developers and amongst teams. So you can share that those definitions from development through test and even into production. And OpenShift is based on the industry standards. It's based on Red Hat Enterprise Linux, we call RHEL, and it's also based on Docker and many others. So containers. Containers have been around for a long time. About 5-6 years ago, when OpenShift, the project, the open source project was started and Red Hat was involved, they've decided from the start to use containers. So they had that insight and that vision already. Another example of that is Google. They have been using containers for many, many years. So about 2 or 3 years ago, Docker came along, and what did they do? How did they make containers so popular? I'm not going to go into detail about the features of Docker that can be easily read on the internet, but they simply made Docker containers consumable and easily usable by developers. So they provided them for developers so that developers could easily use them to create their stacks, instantiate containers, run them, and also, very importantly, share them and reuse them. And Docker created Docker Hub. That's the community today where developers can upload their images, share them, and reuse them. It's extremely popular. So Docker containers are generally immutable. So what does that mean? It means that once they're created, they're set in stone. They usually are not changed at all, right? And this unit forms a unit of collaboration between the teams in the pipeline. So this unit can be passed through development, testing, staging, and into production. So it also encourages microservices. Microservice architecture can be highly complex. You can have dozens or hundreds of services, and each service could have dozens of containers running. This creates a highly dynamic and complex system. You cannot manage that manually. So you need cloud technology in the form of a PaaS to automatically manage that system. Okay? And OpenShift is designed for microservices architecture. So Red Hat decided to use Docker technology about 2 or 3 years ago, and they also decided on an orchestration engine. And they chose Kubernetes, which is an open source project by Google. It's a highly active project, has many, many commits per week, and it provides basically the orchestration, when containers are started, how long they run for, when they're stopped. It also can group and aggregate containers together and act on them as one unit. It has self-healing, so if a container should fail or the underlying host, which is running the containers, fails, it's able to spin those containers up again. And has discovery as well, service discovery. So a container knows how to find another container and connect to it. So if you take Docker and you take Kubernetes and you try to put together a platform yourself, you're going to run into problems. It's not easy, especially how are you going to keep it maintained and updated? Are you going to be able to add all the bits and pieces that are needed to make a true platform as a service? It's going to be difficult. So this is where Red Hat comes in. You can do it the Red Hat way. Red Hat will take the source code. Red Hat's always working actively within the open source communities and takes the source code and turns it into a well-rounded product. So Red Hat will test that code, harden that code, support it, provide training, etc. So it becomes a product which an enterprise can consume. So you have to ask the question, how will you be sure of security? How will you be sure that your container images you're using do not contain any security problems and defects like Trojans. Red Hat provides Red Hat Enterprise Linux as a secure foundation for this platform, and also provides images which it will keep up to date and patch for you. How will you be sure about the scalability? Are you able to test your platform that it will scale and the performance will still be good? Red Hat will be testing the software all the time, including performance testing. So you can be sure that the software will scale. What about integration? Will the platform integrate with external systems? Red Hat does this testing and integration certification work. What about management? How are you going to manage it? Keep it up to date, maintain it. Red Hat can help here as well. So let's take a little bit a look under the hood. These two layers here, the container orchestration and cluster services, and also a little bit more below is Kubernetes. OpenShift adds a whole lot more to turn it into a rounded platform as a service. So you can see at the top here, OpenShift self-service. Obviously, developers need to access OpenShift and use it and create their systems. And they can do that by reusing the middleware and data services. They can also access the service catalog and build their applications. There's also the OpenShift application lifecycle management. Applications can be built, or there are tools and processes built in to build your applications and also maintain them, deploying them and upgrading them. There's also, a little bit lower in the blue box, networking. OpenShift comes out of the box with an overlay network, or in other words, a software-defined network. It's built in, it comes with it, and it's also very transparent. You can just you just know that it's there. It really doesn't have to bother you, but you can replace it if you want. Storage. OpenShift also supports stateful applications, so you can install your database in there. It's not just for stateless or ephemeral applications. A Docker registry comes with it and is built in. Telemetry, what does that mean? That means there's an optional, you can optionally install logging, aggregation, and you can optionally install monitoring, so metrics collection and monitoring. Security, it's all backed by Red Hat Enterprise Linux and SE Linux. And you can choose to run it on Red Hat Enterprise Linux or Atomic Host. What is Atomic Host? Atomic Host is a new distribution based on RHEL, and it's been hardened, and it's a small footprint, and it's basically optimized for running containers. So this is what Red Hat called community-powered innovation the open source way. OpenShift Origin is the open source project behind OpenShift, right? So we call this the upstream project. On the left are all of the open source projects, hundreds of them, small and big, that make up OpenShift Origin. They are the upstream projects, Origin, and OpenShift Origin is the upstream of the products on the right. Those three products on the right are Red Hat's hardened and rounded products ready for the enterprise. Red Hat will give back. Well, Red Hat is very involved with these communities, so any fixes, hardening work, all that goes back into the open source community. And this creates a cycle of innovation, a cycle of open source innovation. And because it's open source, by the pure definition of open source, it cannot be broken and it cannot be stopped. So on the right, the three products. OpenShift Enterprise, that's the version that you can subscribe to, and you can install it on any platform or on-premise or in the cloud. You would have to maintain it yourself, of course. The next one is OpenShift Dedicated. That is a cluster of OpenShift, which is provisioned by Red Hat and maintained for you by Red Hat. Online, OpenShift Online is the usual type of cloud service. It's on demand and pay per use. Interesting with OpenShift Online is that there's a free tier and it's unlimited with time, so you can you can deploy 2 or 3 containers with small applications and let them run forever. So you can see from the numbers here how successful OpenShift Online has been. I'm not going to go through the numbers, but you can read them for yourself. Now, it's important to note that the current version of OpenShift Online does not support Docker. It supports a different type of Linux container technology. Version 3, which is right now in pilot, will be available after the summer. Okay? So when you log in today to version 2 OpenShift Online, you're going to read about cartridges and not Docker containers. Right? So if you're reading about cartridges, then you're looking at the old version. I recommend you read about the newer version, which is coming very soon. And all of this is also running on Amazon Web Services. So let's have a little bit look at OpenShift Dedicated. It's built and managed by Red Hat, so you can rely on Red Hat's engineering and operations and support. This is what you get. So for the base package, you get 4 instances. All of the hardware, all of the infrastructure which makes up the, let's say, the management of the cluster, of the OpenShift cluster, all the masters and all the infrastructure nodes, they're all highly available, and they're all included in the price. You can attach EBS volumes to your containers, and as usual, the Docker registry comes included. Now, it's important to note that all of this is provisioned and maintained inside Red Hat's virtual private cloud, not in your VPC. So you don't have access to that VPC, but you can connect to it. You can connect your on-premise data center to the Red Hat VPC where OpenShift Dedicated is running, or you can create your own VPC and connect through the private network, Amazon Web Services private network, to OpenShift. And accessing OpenShift Dedicated, developers and the sysadmins obviously access over the internet. So this is a very high-level architecture view of OpenShift. I'm going to now go through a walkthrough. And why do I want to do this? Because I want you to gain an appreciation of what or how OpenShift works so you can understand what it offers. OpenShift will run wherever RHEL will run, and that is very flexible, so it can be physical, virtual, private, public, or even on your developer laptop. There are 2 main components to OpenShift, the master and the nodes. And the compute nodes, that's where your application will run. Those nodes can either be RHEL or atomic host. So your application containers run on those compute nodes, and they are called pods. So how do pods come about? How are they created? OpenShift comes with a built-in registry on the right. When a container is instantiated, the Docker image is taken, it's pulled from the registry, and a container is created. That container is then put into a pod, and a pod is nothing else other than a container itself. A pod can contain 1 or more containers. So why do we do that? In many complex applications, you need to have containers, sometimes you need to have containers close together. So, for example, they might work more cohesively together. They can share resources like, for example, a file system. One might write to the file system, one might read. Or they can use interprocess communication, for example. So that flexibility is there. The other thing is a pod works as a single unit. When a container is created, it's created as a pod with all the containers inside. And if it's scaled, all those containers within those pods are scaled with it. So it's 1 unit. Yes, and then also a pod gets a virtual IP address. So it's like a virtual host. That's essentially what it is, a virtual host. So then the other component are the master servers. These are the brains of the system. They keep the state of the cluster. So let's go through what the master does. The master has an API against which you can authenticate. Everything, all the requests coming into the system go through the API. So all the requests from the web interface, from the command line interface, from various developer tools, they all go through the API. There's also authentication. There's role-based access control. I can define specific access to the cluster for developers, which might be very different to the access from administrators. You can also define projects, which is basically just a namespace, so that developers from different teams can work in different projects and they don't stamp on each other's toes. The master also has etcd as a key value data store. That's not persistent for your applications. It's not persistent storage for your applications. It's persistent storage for the state of the cluster, for maintaining OpenShift. Now, how it works is this. Some of the components of the system might write to etcd, and some of them might be watching for changes, and they'll see the changes and then change their state to that effect. So one example is a user might request for an extra pod to be created, an extra container. The replication controller will notice that and then instantiate a new pod. Now the scheduler, that's what decides where the pods should be launched onto which compute node. Now, by default, that can be more or less a random compute node. So how else does the scheduler decide where to place the pods onto which nodes? It can use metrics, for example, CPU. If the CPU utilization is not very high on a particular node, then the pod might be placed there. Other ways are using labels. So you can label a set or a group of nodes. As an example, so the top 3 nodes, you could place them or label them to be in availability zone A, and the bottom 3, you could label them to be in availability zone B. And then you can use affinity and anti-affinity rules to ensure that pods are placed into those groups. So anti-affinity rules would mean the pods would be placed into both, evenly into both groups, into both availability zones for high availability. And affinity rules would mean that the pods would stay within a group so they can work more cohesively together. So, if pods can seemingly be randomly placed onto nodes, how does one pod know how to find and connect to another pod? Does a pod have to keep track of all the pods in the system? No, certainly not. So that's where the service layer comes in. The service layer is an object. It's kind of like a middleman or a proxy. It keeps track of a specific pod or a specific set of identical pods. And it provides a static address for other pods to use to connect to. And that address could be a static IP or a host name. The service also keeps track of all of the identical pods which it is managing. And if a pod should go away or if pods should be added, it takes away it basically maintains a list of those pods. And the service object acts as it's basically effectively an internal load balancer. So you can use it, for example, if you've got a multi-tier architecture, that might be your internal load balancer between the tiers. Or if you've got a microservices architecture, it would be the load balancer separating the different services. So the replication controller, that's the part which decides when pods should be started, how long they run for, when they're stopped. And should they fail, so for example, that pod there is burning down, it's failed, the replication controller will discover that, and it will ask the scheduler to replace the pod on a different node. And whilst that's happening, the service layer will keep track. It will realize that pod is gone, and it will take it out of its list and stop sending connections to it. When the pod comes up on a new node, it will add that pod to its list. So you can use persistent storage in OpenShift. And the way it works is this. The administrator will carve out a pool of storage, And the developer is not really concerned about how that storage is managed. The developer just needs 100 gigabyte and will request for that chunk of storage and connect that storage to his pod. So that means that the application is reasonably separated from the type of storage. So you might go through development. The developer might be using very simple storage or NFS, go through testing. Maybe we're using something more sophisticated. And in production, they're using something, for example, like iSCSI. Like I mentioned earlier, OpenShift comes out of the box with an overlay network. But from an external network into OpenShift, there is no route. There is no route into this overlay network. It cannot be routed. So we need a routing layer that basically enables connections coming into OpenShift to be routed to the correct pod, or routed to the correct pods if it's load balancing. So developers and administrators can access OpenShift through the API. They can use the web interface, the command line interface, and various plugins. For example, they can use their IDE to interact with OpenShift. Jenkins is a great example. Jenkins plugin can do that, or Jenkins can use the command line interface to interact with OpenShift as well. So that was the walkthrough. Now I'm going to touch on something else. This is called source to image. This is another open source project which is embedded into OpenShift. This is a great way for developers to build images. If they use this, they do not necessarily need to create Docker files themselves. And the way it works is this. This builder image, usually provided by Red Hat, is specific to a language, right? It contains all that, for example, PHP needs, all the dependencies and libraries. When the developer wants to build a new image using this image will be instantiated as a container, and the source code will be injected, and the application will be built. But in the case of PHP, nothing is built, but it's just injected there. Once the build is complete, a new image is created and put back into the registry. So once it's put into the registry, it can also trigger automatically a new deployment of that image into the cluster. There's another interesting thing about this is that if these images are maintained by Red Hat, and Red Hat patches these images because of a security vulnerability, you can automatically detect that and set the whole process in motion again to rebuild the new image and automatically deploy that image into your development environment. So I just want to touch on this, DevOps. OpenShift can be a driver or a catalyst for DevOps because it comes with a lot of the automation, standardization, and the processes which are needed for DevOps. So if you put your best team in front of OpenShift and you teach them OpenShift, or you bring that team into Red Hat's incubation lab, you will learn how to use OpenShift, and you will learn a lot of the DevOps processes. I'm not saying it's the solution for DevOps. It's not a silver bullet, but it can facilitate your journey through DevOps. Here's an example of one of our large customers. If you make a flight booking or a hotel booking in many countries of the world, it's very likely that booking record will be stored in Amadeus's data center in Germany. And they have a huge load, look, over 1.5 billion requests per day, for example. And what does Amadeus get out of OpenShift? They have this unified process, and it basically means two things. They can define an application made up of all of its containers and how they interact together, And they can take that definition as an OpenShift template, and they can move it through the development pipeline, development, test, staging, and even into production. And they also, because you can install OpenShift anywhere, in the cloud or on-premise, for example, they can be sure that they can deploy that application into any of those environments. And that's something that they want to do. Because they only have a data center in Germany, they want to be able to exploit the cloud so that they can be closer to their customers. And because latency is very important for them. So if you want to go away today and you want to try out OpenShift, the best way to do it is using Amazon Web Services Test Drive. You can go there, fill in a form, and a cluster will be spun up for you. You can use it for an hour or two, I think. Another way is you can install it on your laptop. And what I recommend you do is install the Container Development Kit, the CDK. If you go to this URL, tiny URL, Red Hat CDK, you'll come to a blog article which explains all about the CDK and how you can use it. And I'm happy to say since a few weeks, Red Hat have at last created a free developer subscription. So with that developer subscription, as a developer, of course, you can run the full version of Red Hat software. And of course, Red Hat is renowned for its training. We have training available for OpenShift. There are also free books available. Kubernetes, Docker Security from O'Reilly. There's also the Three Little Pigs coloring book. It's an interesting read. You can learn about Docker. When you're finished, you can give that to your kids to color in. OpenShift has won many awards. So I cannot even list them at the moment. It's a huge project, red hot. It's really, really active. So you can rely on Red Hat because this is it's such an active project, and Red Hat is basically supporting and maintaining this very well. So I hope that you've got out of this talk that A, you know a little bit more about OpenShift and how it works, what it can offer, and especially that you can run your containers using OpenShift in any environment. So I want to thank Amazon Web Services for having me to talk, and I also thank you for staying here until now, not falling asleep. Thank you very much.